Welcome back. We're going to continue our lesson today, section 7.7 on the 7.5 on the volume of a region that's revolved about the x-axis. What's going to be different today is that we're going to have to find those points of intersection, or our endpoints, our boundary, our upper bound and our lower bound. So just a reminder, our volume of a figure is going to be pi times the integration from a to b of that top curve squared minus the bottom curve squared. And remember, our top curve is the curve that has higher y values for that given region. So in example 1, we have f of x equals x and g of x equals the square root of x. Notice here we don't give you any endpoints. So we're going to have to find them. Well, to start, I would suggest that we go ahead and calculate or graph it. And we can use our graphing calculator to do that, or we can remember what these functions look like. F of x equals x. Hopefully, that's a nice diagonal line for us. We can go ahead and label that as our f of x. G of x is the square root of x. So the square root of x is going to come up, and it's going to come out something like this. Now we should hopefully see that we have this small little region in here. And if we put this into the calculator, we have our x, and we have our square root of x. And if we graph that on a standard window, it's going to be very difficult to see kind of what's happening there. But we could zoom it in there. And if we zoom it in, hopefully now we can see a little clearer what's happening. Here's our linear function, and our radical goes up slightly above that. So we got to find these points of intersections, lower curve and or the lower bound and the upper bound. So we can do that with the calculator. We can do second trace. We can do number 5. We need to enter, enter, enter. So we get the point 0. We can also find that second point by doing, again, an intersection point, but then moving that cursor to the right so it's closer to this other point of intersection. And we get that point of 1. And again, remember, we're looking for the x values since we're revolving it about the x-axis. We can also do this by hand. Remove the calculator there. We could take x and set it equal to the square root of x. This is only if you don't have a calculator. If you have a calculator, you don't necessarily have to do this part here. So to solve this, we have a radical. So to eliminate that radical, we can square both sides. So x squared is going to equal x. I have a quadratic function now, or equation. I can subtract that x. So I get x squared minus x equal to 0. Solving this, I can factor out an x. So I get x equals 0 and 1. So notice again, I get those two values that I had found with my calculator. So with a calculator, find the points of intersection. Without a calculator, setting the two equal to each other and solving for x. So now what does our volume look like? Well, we have pi times the integration from those two endpoints, 0 to 1. Our top curve, which is the square root of x squared, minus the bottom curve, which is our x squared dx. And hopefully, again, remember, we're looking for the one that has the higher y values in that region. So this radical has higher y values until we get to 1, then it has lower y values. But we're only interested in that region that's created by those two functions. So again, we can utilize the calculator. If we go back to our main screen, we can go back to our main screen. We're going to have pi times the integration, so math 9, from 0 to 1. The square root of x squared is x minus x squared. And then our variable of integration is x. So our volume for this figure is 0.524. As we look at example 2, which will be our final example for today, nice quick lesson, I guess. Again, nothing miserably different here. We're looking at x squared. So there comes in x squared. We're looking at x plus 2, so maybe something like that. So we're finding, again, these 2 points of intersection. Again, I'm going to utilize the calculator. It's a little quicker. Hopefully, though, you can do it by hand if you need to. So x squared, and we have x plus 2. We're going to go back to a standard window for this example. So here comes in our x squared, here comes in our x plus 2. We can calculate the point of intersection, and we get the x value of -1. We can go ahead and do that again. This time, though, we're going to come over with that cursor, and we get 2. So our volume is going to be pi times the integration from -1 to 2. Our top curve is that linear function, x plus 2 squared, minus the bottom curve, which is going to be x squared. And our variable of integration is dx, or x. So again, we can utilize our calculator when we do this. We can go back to our main screen. We have our pi. Then Math 9 gives us our integration operation. We're going from -1 to 1, or -1 to 2, sorry. But now we have this x plus 2. We could square out x plus 2 squared, or we could utilize the variables that we have, remembering that x2, or x squared, was in y1, and x plus 2 is in y2. So if we think about this as y2 squared minus y1 squared, then we can come over here to our integration, in our integrand, and we can pull up y2, remembering that it's in vars, go to y vars, and then number 1 allows us to pull those things that we've stored into our y equals back in the graphing screens. So we're pulling y2 out, so we'll have y2 squared minus, we're going to do the same thing, we're going to pull back y1, or you could type in x to the 4th in this case, probably just as easy. So we do our vars, y vars, function, and then this time it's going to be y1 squared, and we're still in the variable of x. Hitting enter, we end up with a volume of 45,239. And that's going to give you a couple of examples on having to find those points of intersection before we can go ahead and find the integration or the volume. Happy integrating!